I think our industry is at a point where we have to give back. I mean, we're falling behind in our talent. We're falling behind in refilling our pipeline of the next generation of PCB designers. And I would recommend everyone to go through the history of a printed circuit board, where we've come from, some of the leaders of this industry. They still exist.
Hello, everyone, and welcome to the Altium On Track podcast. I'm your host, Zach Peterson, and I'm very happy to be talking with John Watson, Customer Success Manager here at Altium today. John Watson is well known as a webinar speaker, and he writes in iConnect, and of course, he helps with the education program. He does so much for Altium and for the industry at large. John, thank you so much for joining us.
Well, thank you very much, Zach. It's a pleasure to be with you and have this time with you.
Well, pleasure's all mine, actually. We have a lot of folks on lately who have been talking about some of the areas in which you are involved. And I think you are involved in things like education for designers, education
Mm-hmm.
for Altium users, and then education for people in the industry at large through some of the work you've done both on the Altium blog as well as in iConnect.
Right, exactly. It's definitely a passion of mine. I've actually taken to heart some of the statistics, and we've talked about in the past some statistics that we're seeing in the industry and some shifting that's going on, and actually some concerns that are arising in our specific, in the design process itself and different things like this, of filling the pipeline. We're seeing a lot of retirements involved. People are leaving the industry or changing their careers. And it's really a passion I've got, is to kind of mentor the next generation, we'll say, of new designers coming in.
So one of the things that you do, as I mentioned, is of course, writing and blogs and webinars, but you're also working, I guess you could say, in the trenches or on the front lines, educating
Yeah.
designers. So you work at, or you teach a course at Palomar College.
Yes. Palomar College, San Marcos. I am their adjunct professor there of teaching basic and advanced PCB design for a total of 32 weeks out of my year. And we have a class, really kind of a mixed class of young people, middle age, and seniors that are going for career changes, different things like this. So it's really interesting to be in the trenches, as you say.
Yeah, you were very gracious to invite me to sit in on a session with a couple other folks, and I was, I don't want to say surprised, but I guess you could say pleasantly surprised at the cross section of students that you had, because like you said, you did have a few older folks, and it
Hmm.
looked like you had some younger students who were, in that typical college age range.
Yeah, and actually, we have a special program at Palomar College, and that is what's called the Middle College Program. This is actually geared for high school students, the juniors and seniors in high school that would like to take begin to start taking college courses. I actually had two of my students that, when you attended, that were in still in high school of all places, and we're now taking college courses in PCB design. So was really exciting to watch. The younger people are now, I think, becoming a lot more interested in this side of it, with their different programs they may have in their high schools with STEM programs, and robotic teams are huge right now. And looking at how this all works together with printed circuit boards and all that, it's really an amazing field, and I think it's definitely picking up some interest now from what I'm seeing on the educational side also.
Yeah, the educational side is or has been brought up a number of times by longtime industry veterans who we've had on the podcast,
Hmm.
and the point has been made repeatedly. Onshoring is great, whether it's semiconductor or printed circuit board, um, but if you can't find people who are qualified to work in the industry, either as designers or as process engineers, just working on the line, none of that really matters.
Right, exactly. And I think we've gone full circle now in the industry. From what I'm seeing, is that several maybe 12 years ago, maybe during the economic downturn of 2008, we actually saw where companies were now looking at using. They didn't use designated PCB designers any longer. It was where they said, okay, we'll go over to the double E's. We'll use them as to build and design PCB designs. And then it turned out they quickly found out they didn't get the education they needed to do this. If you ask a typical, or I won't say typical, but if you ask a double E, just ask them, how long did you spend studying just printed circuit board design? The most I ever heard was like 6 weeks. I mean, and it was like, well, in 6 weeks, you don't, as we know, we don't grasp even the concept of printed circuit boards, right? I know I've been studying this for decades now. I think I'm coming up on 24 years of studying this, and I've only scratched the surface of this. And just isn't it amazing? Just about the time you nail this all down, it changes. It's right. So going back, companies were now focusing on the double E's. Okay, you're going to be responsible for this, and then now that's kind of run its course. Now the double E's, we're finding that they're going into other fields of interest, not into hardware engineering or different things like this. I think there's a trend. I think we talked about statistically that we're seeing a bigger focus on computer sciences and things like this, and even on maybe the software side. Hardware development, hardware engineering is sort of now lagging, really behind on what's the industry needs. So now, to tell you the new trend that's happening now is companies are now calling and just saying, calling me as a professor, saying, give us anybody, just give us a warm body that will train, and we'll get them started in this industry and everything else. And I'm even questioning whether the warm body is required at this point. It's like, just give us anyone, and it's really the case. So this is why I'm in a really unique position. As the professor, I have the opportunity to work with new students, new designers, people who are looking for maybe a career change or different things like this. This is actually how I got involved with the industry. I don't know. It's often believed that you kind of have to follow a path or be a double E or do no, you don't. Not with printed circuit boards. It's something which you can actually break into or learn, and actually change your entire career. That's the way I did it. I came into this industry as an electronic engine or an electronic technician of all things, and then shifted my career into PCB design. And I can tell you that there's no set path for this, which is really exciting. So I have the opportunity to work with those new students who may be looking for a career change, or the ones that are experienced, who are looking for maybe a new, going deeper into the subject and for things like this. But then also working with companies that now have open opportunities, and then making that connection. So it's really it's really exciting to watch that all kind of happen in watching this person. I mean, this is the most thrilling part of my job, is watching a person who comes into that first class and says, I don't know anything about printed circuit boards. And when they get done after the basic and advanced class, coming out the other side and then getting into a position as a printed circuit board designer or something like that, it's so exciting to watch that. It's really thrilling to see that all happen.
You brought up something interesting, which was companies about 12, 13 years ago were making the shift of not having dedicated PCB designers.
Hmm.
And I would imagine that at the time, the justification for that was productivity, or was the
Yes,
thought that, hey, this is an electrical thing, this person's an EE, bam, they should know how to do it.
right.
And very quickly, everyone finds out EEs are great at a lot of things, but if they don't have training in this particular thing, then sometimes it's not so easy to do.
Right, exactly. Yes. No,
And then the other thing you brought up that I think was interesting, which was just confirmed by something I saw on LinkedIn, was kind of the opposite pointing trends for computer science, software, things like that versus
mhm,
hardware. It's like a linear slope up for computer science and software graduates, and a linear slope down for hardware EEs and PCB people.
right. Exactly. Now, I do see that possibly changing here as I'm working more with educational side, working with colleges, universities, and different things that they are now interested in getting more of the PCB design programs in place. So I'm actually, that's kind of another side of my business, not business, but my job is to work with them to help them get started and to get their program set up, their curriculum, and different things like this. And I am seeing a shift now into universities and colleges that are interested now in teaching this as a detailed individual subject, which is really exciting.
So I would imagine they're teaching this like as an elective or set of elective credits in a larger EE program.
Yes, yeah, exactly. I was recently at a conference of department heads for universities, and they asked me, "Well, how long is your program?" I said, 32 weeks, 2 semesters, 16 weeks each. And they go, "Well, what do you teach in 32 weeks?" And I go, "Well, how long is yours?" And they go, "Well, it's like 6 weeks." They go, "What do you teach in 6 weeks?" It's like, you know, it's like, wow. I just start warming up in 6 weeks. It's just like, okay, this is such a complex subject. There are things that I actually have to cut out in that 32 weeks, but it's a between the basics and the advanced class, we cover a lot of great detail on the what my main focus in these courses is to in the basics class is to give them the PCB design process. All right. We give a little bit of an introduction of PCBs and history and a little bit of that, but then we get right into the design process and actually making this as practical as possible to the student. And their very first board they do in this class is a Mars rover controller board, which is like complex. I throw them in the deep end of the pool, as they say, which is fine as long as they don't drown first, right? Before they learn, right? So the advanced class, we begin to focus on some very specific then details of the PCB process that that first off we look at the fabrication and manufacturing process. We actually visit a fab house and see how all this comes together, so the student understands, okay, I just don't throw my data over the wall basically and it magically falls back, the board comes back to me all done. I want them to understand how this all happens, including that process, the fab side. Then we go into rigid flex design, we go into advanced PCB design, we go into then system design at the very end. So it's a really broad section snapshot that I've got. But even that, I look and go, my goodness, I'm cutting out so many other subjects we could cover, different things like this. So 32 weeks is like a full packed 32 weeks. It is like intense. Um, so it's not for the faint of heart, but my students are really top notch, and we do go through this step by step, and they are phenomenal students, as you know, you've met them, so it's a major part of this, I think. Um,
Do you find that a lot of students are getting interested in this kind of as a maybe a skill buffer or just as a complement to their skills for when they move into the workplace? Um,
yeah,
or,
yeah.
or are they like just full on like I want to design PCBs for the next 30 years?
I'm seeing a mixture. I'm seeing that, yeah, there are those that say, yeah, this is, I love the concept of PCB design and the solving the puzzle and all this, right? And then there are those that are understanding that companies are not just looking for printed circuit board designers. That's very rare. They do have that, but it's now where that person will be responsible or be in at least involved, we'll say, with other processes or other steps in that design, that the entire design process, meaning that they may be brought into the mechanical side a little bit, or they may be brought into firmware or different aspects or other disciplines here. So I do think that a lot of the students are understanding that now a lot better. So they have to see, okay, I should have a better skill in this area or that area. So they're actually better, well-rounded designers now. I think what I'm seeing is they're not just concentrating on PCB design, which is great, of course, but they're also seeing, let's say, the mechanical side now. Let's work on that side, or let's work on the firmware, or different things like that. So that's really what's happening now. I think a lot more. They're much broader, talented students now.
I mean, that's very encouraging to hear that there is a crop of young people who are getting into this and
Hmm.
who really see the value. I'm wondering what it is that kind of kicks off that initial spark and then exploration. I
Hmm.
I have noted that, at least from my own experience in the past, that when people talk about technology, especially 10, 15 years ago, when I was much younger, people talked about software, of course, but it was semiconductors. Like,
Yeah.
you were either doing computer chips or you weren't doing anything,
Right.
or you were going into computer programming because, of course, we had the internet boom, and then we had all the software companies coming up, and then everyone starts seeing Silicon Valley salaries, and they say, hey, I want to do that. And
Hmm.
and I think that helps get kids into technology, but it was really detrimental to creation of a new generation of hardware engineers, and that's why you get kind of this upward slope on the number of computer science and computer engineering graduates versus the downward slope of hardware engineers and specifically electronic engineers.
Oh yeah, yeah. I would agree with that. I do see that. Um, it, it has been and this shift has been going on for, my goodness, like we talked about, 12 years at least. I mean, or even I would say 15 years. I mean, PCB Fabrication Magazine every year puts out their survey saying, okay, do you intend to retire in the next 12 months? And the numbers have just been overwhelmingly 60% and up in that level. And it's just like, wow, we're, I talk to companies. I was speaking at a conference several weeks ago, and I opened by saying, "Has anyone else heard the massive sucking sound coming from companies? It's the talent walking out your front door, and that's really the case. It's where companies are losing their talent every single day by through retirement, through career changes, or whatever it would be." And we have to fill that pipeline. And what I'm seeing is, it's to kind of look, to answer your question. I don't I think it's a combination of things right now that's driving the interest of printed circuit board. I think a lot of it has to do with outreach and looking at the new STEM programs and robotic teams, all this. I mean, it's definitely changing. I see that, but it's what really attracts somebody into this is just the mentality. I think it's a lot of it is just the mentality of being innovative, the of looking at new technologies, wondering how that works. I mean, I'm going back to my own career, and looking how I got involved in the into this. It would be where I would be in my kitchen floor with a screwdriver and this toaster. It would be, in that sort of environment, right? It was like, how does this work? How does this all come together, right? And so it's where they want to go in, and I think then what attracts someone into it then is just the fun of it. I mean, PCB design is fun. It's like, wow. I mean, it's like solving the puzzle, you know? And we understand this because we do this like every single day, right? We see that initial PCB come up when we pushed it from the schematic, and we see the rat's nest and all these different things, right? It's like, oh yeah, here we go, right? It's like it's an excitement that's involved, and see, that is really, I hope we never lose that. I hope we never lose that sort of wonderment about PCB design. I see some things on the horizon that are concerning to me. I mean, we see AI coming up, for example, and all these different things. I do not allow AI in my class. I don't want to. I point and hope that my objective is that I develop critically thinking students that will look at a problem and be able to solve it and to see the solution and to work it that way rather than just say, what's my answer? That's not the approach. It's not saying, okay, the tools that you want to develop here are not just saying what is my answer to the problem. Is saying, how did I get there? How can I critically think, and how can I go through the problem solving answer, or the problem solving to actually solve the question that I'm looking at. So it's really kind of an interesting predicament. But yeah, I think it's that wonderment that people have, is that, okay, sitting on the floor going, okay, how does this work? I want to know. I want to break this apart. You know, I stopped doing that, by the way, after my parents bought about two or three toasters. I mean, so it was like, okay, I'm not going to do that anymore, right? So, but yeah, it was. So it's just a wonderment. I love printed circuit board, and right, we both love printed circuit board. It's our passion. It's really what drives us and gets us out of bed every morning. Just to say, yeah, another day to work with printed circuits. I mean, it's like an exciting field to be in.
Absolutely. Yeah.
Yeah.
100% to support that statement. Um, so, as students get into this area, what are you noticing are some of the challenges that they face? Is it maybe a mindset shift? Is it tool control or tool usage? Is it just getting familiar with the concept of CAD tools generally? Are they finding that, hey, this isn't the type of thing I expected? Is it the workflow?
Um, it depends on the student. First off, I find that I have a really kind of a mixture of students, and let's break these down into the groups I see. Number one is I see the first time designer. A lot of times these are individuals that are coming from other industries, other disciplines, things like this. They have seem to have a less of a challenge with the printed circuit board process. They're a lot more open to look at it and to look at it as a whole than the another group here we'll talk about. So I find also, by the way, that a lot of artists get involved with printed circuit board, and this is something I've noticed. You look at some of the best printed circuit board. I could throw out names right now that were like are leaders in the industry. They actually came from the artistry side. They're
Interesting.
artists. They're artists in some way. They were like the sculptors. I can name you a sculptor right now who's world famous sculptor who was a printed circuit board designer. There's yeah, there's another one who was a landscaped artist, things like that, and they naturally saw the connection between printed circuit boards and artistry. All right, so they see it as an art. They see it as so their mindset on that is that they're much more open to, okay, I'm not concerned about particularly the details. All right, I'm more concerned about the overall picture of this.
The
Now,
elegance, if you will.
the elegance, exactly. Now, the other side of this is the double E's. All right. I have several double E's in my class, and when they approach a printed circuit board, they'll lay a track down or a route, for example, and they'll say, "Is that right?" They're more of like this right and wrong aspect of it, and they're wait a minute. Is that the question I'll go give back to them is this is it's not a question of whether this is right or this is wrong, but does it work? All right. Does this fit into your and does this fit into your overall picture or image of the printed circuit board itself? Right. So it's kind of a much it's difficult to kind of break them out of that of micromanaging, we'll say, of the printed circuit board itself, of saying, okay, you're looking. I tell my students, here's your printed circuit board. I'm going to give you there's a schematic. When you give me back your board, every single one of these are going to be different. They're going to be unique of how you lay them out. Of course, there'll be the there will be the common things such critical placement of this connector or that or different things like this, but every single board will be different. And what I do is I actually then bring up each student's board and let them see what the other student has done, how they've interpreted that design. All right, and this is probably I can clearly see these divisions between the students when it comes to the layout itself. The one side you've got the artistic side that says, okay, I this works, this is my interpretation of this, and then the engineer goes, well, is this right or this wrong? It's like, well, don't just you're going to have a set, of course you're going to have a set guidelines, of course, with the design, but how you solve the puzzle is up to you. Yeah.
That's funny you bring up the, is it right, is it wrong thing, because I'm going to go back to my experience when I was doing my graduate work. I
Mm-hmm.
took, as one of my elective credits, a semiconductor device design class. And unfortunately, they didn't offer, printed circuit design. Maybe I would have taken it, but I took the semiconductor device design class, and it was the same kind of thing. You're given these problems
Mm-hmm.
where there is no specific right or wrong answer. It was a design problem, and you're just going to get into a range of acceptable values. And for me, that was a big struggle for me because
Right.
coming from a physics background, and a lot of engineers come from the same type of training, we're always
Mm-hmm.
given these homework problems where it's like there is an answer, there's one answer,
Right.
and you may have to defend that answer and justify the answer, but at the end of the day there's one answer. And you do this for years with all the homework that you're given, and then to suddenly shift and say, well, no, you just have to hit this kind of target area with this thing you're building. I think it is a
Mm-hmm.
big I think it's a bit difficult for people who come from hard sciences or who come from a typical curriculum to make that change.
Right. Exactly. And I've seen that very, very clearly in my class. It's where they and a lot of times it causes people to kind of bind up, we'll call it mentally bind up. It's where they go, oh, it's like I've got to know whether this is right or wrong. I need to have it right. Well, okay, great. But how do a lot of times they'll get I hate to use this word, but mentally constipated of making decisions based on whether that's right or wrong in a printed circuit board design. I'm saying one of the things that I'll have my students do all the time is turn everything off. Just turn everything off and just look at the board. Just I will actually have them turn off all the layers. Just look at that rat's nest. Just stare at it for a few minutes, and you'll begin to see how those connections are. You'll see where they're going. You'll see where things are much clearer. A lot of times we get into this into just seeing too much and too much detail. It's just clear the board. I mean, one of my favorite movies is In Search of Bobby Fischer years ago, with Lawrence Fishburne was a part of that. Several other great actors, but it's about a prodigy chessboard player, and he was great chess player. And um, Ben Kingsley, who is the coach for this young child, has this puzzle, a chess puzzle in front of him, and he goes, "Do you see it? Do you see the answer? Do you see the solution? And he goes, I don't see it. I don't see it. And great advice here. Ben Kingsley gave was, don't move until you see it. Don't move until you see it. And he still doesn't see the solution here. And what Ben Kingsley does is he completely throws all the pieces on the floor. All right. All the kid sees now is a blank board, and he goes, now do you see it? All right. And then he got it. He solved it. Sometimes we get too much in our designs, we get too much in our lives, we get too much in all these other areas where we're just so cluttered mentally thinking. And this is where I find a lot of the double E's and different things do have problems with printed circuit boards because of that. Is they just overanalyze every single piece of this when they should just be clearing the board, thinking, what is my solution here? Just understanding what your next move is. You know, not having the whole thing solved, but just your next step. You know, and yeah, there's definitely groups that I see um, how they handle printed circuit boards. It's a whole science unto itself now. It's really amazing.
That's really interesting how you said that some of the best designers that you've met are artists. I guess we shouldn't be
Hmm.
surprised though, since fabrication outputs are sometimes called artwork.
Yeah, exactly. Yeah, it's where if you look at a a multi-layer board, 16, 17, and it is art. It's absolute artwork, and it's there's a real beauty behind it. And in I think it's more important to understand the steps or the process of how do I get from here to point A to point B, for example, in my design, rather than saying, okay, is this trace exactly where it should be, or this trace or that trace, and different things like this. We're not developing. I would hope we're not developing in our PCB designers that we just here's your answer, copy your answer. All right, I mean, this is what's going to be unique about every printed circuit board design is that everyone's going to be different. Every single PCB is going to be different. Everything is good, and what's amazing is they'll work being different, you know, and that's what's important here is that yes, there are the engineering and the physics behind all this and everything else, but there's definitely that differences in that design. They're still work. They'll work just fine. So
I think what you've brought up here is a new way to think about engineering design generally, or engineering design education, which is constraint-based thinking, because
mhm.
that's really what we're operating within is a bunch of constraints. And as an engineer, part of your job is to define those constraints such that
Yeah,
you still hit some sort of operating target within the operating targets constraint.
hmm,
So you're
right.
kind of a constraint manager professionally, if you will, if you're going to be doing
Oh
printed
yeah.
circuit board design.
Oh yeah, absolutely. I mean, there used to be where design rules years ago were design rule checks. Now, what you would do is you'd lay your board out, you then bring up your design rule checks and see if what you did lined up to those rules. Well, what they now call them is design rule constraints. Because what they'll, and this is the case with Altium, is that when you lay out something in Altium, it will not allow you to do that if it violates the rules. So what this does is it kind of prioritizes now the design rule checks or the constraints now, I will say, that it will guide you as you do your routing, do the different parts of your board, things like this. But yeah, it's definitely now swung over to the other side is saying, okay, let's set up your rule set first. and then that will guide what you're doing. Um, yeah, it definitely has changed our industry a lot on that. Saves you a lot of repairs at the end also. Bring that, you know. Yeah, you used to be where you made so many violations on your thing that you had to go back and redo a lot of the circuitry, right, when you're doing checks. So yeah, the constraints versus checks is like another whole, it's great conversation.
Well, and it really guides you to that uniqueness in your particular board. Because if I start in one circuit, do the layout there, that then creates new constraints based on placement and routing, where I now have
Hmm.
to route other things to, miss it or satisfy those constraints and
Right.
make sure that I can solve another part of the board. And it's kind of this cascading effect where if you're not careful, you could work yourself into a bad situation where you have to go back and redo stuff, and nobody wants to do
Right.
that. So I'd
Right.
imagine you have to
Exactly.
kind of teach students to see the future a little bit.
Yeah, exactly. And like going back to my analogy of the chess game, it is a game of chess. You have to kind of be thinking ahead. You're when you're getting into your component placement, you kind of have to be thinking, okay, how am I going to route this? You kind of have to say, okay, do I see the solution to the route? Do I see the how I'm going to connect everything up? Different things like this. It's is yeah, you do need to be thinking ahead, thinking what your process is going to be, what your next steps are, different things like this. And this is really why I think this is an exciting area. It is solving the puzzle, and putting everything together in this puzzle, making everything work, right?
Yeah, absolutely. So do
Mm.
you find that students who get into this want to move a bit further into the maybe PCB manufacturing domain, working with materials, working with simulations, maybe going to signal and power integrity? Do you find that that's the case?
Yeah, yeah, they do. It depends on what they want to, what direction they want to go. And my part of my job is to kind of give them the appetizer of, okay, this is kind of the broad view of all this. And then I do find that some of those students want to go into further studies. I have several that I got one person right now who's interested in power distribution, different things like this. Then we've got other ones that are making the connection into the mechanical design or different things. So yeah, it's where this is just sort of opening up new avenues to them to understand now. Oh, okay, so I've got this now. I understand this side of it. Now let's go deeper into this. So
And I would imagine that because you get input from industry to some extent, you're really
mhm.
preparing students to get out from this type of course, finish up their regular engineering curriculum, and then get into some of those more advanced, like industry level courses that you might find at a conference. Is that a fair statement?
Yeah, exactly. There are several organizations that I work with, of giving the student getting into the next steps of what they're looking at, also furthering their education. They understand that yeah, 32 weeks is pretty intense, but this is only at the beginning. This is where they have so much more to learn, and they've got to get out there and start getting involved in the system, into the process of learning. And really, this is where I really think this is my objective by teaching is give them a kind of a desire to learn, to say, okay, I want to learn this area and begin to break into this. This is where the internships become very important, of getting, not just teaching a student, giving them a certificate at the end saying congratulations, you passed my course. It's where they say, well, if you want to do this, there's opportunities now available to you to get into a job, get some money, start earning this, make a career change, or do something that will change your life, really. So this is the opportunity, by the way, that was given to me 24 years ago. All right, as I saw a shift in the industry, in the electronic industry, I saw that a lot of people. I mean, electronic industry technician work was you went down to a component level, you replaced that component, you put the board back into service, right? Then it was just board swapping. Yep, you got a bad board, throw it away. So that's what forced me into the new new career, basically. I said, okay, fine, I'm going to do printed circuit board design, and that's where I started. And I actually went to the same course I now teach at Palomar College um, 24 years ago under a gentleman by the name of Bill Brooks, and he was my professor, and that's where I began. And I then had the opportunity to break into the industry and to start work and to get into this new career, which has been fascinating. So the road can go anywhere from here, uh, but the student, that person, has to make that first step to say, I want to change, or I want to do this. I want to do a new direction, or I want to learn this, or whatever that is. Whatever that initial trigger is for them to make this decision to get involved and to participate or make a change. The opportunities are there. The training is there. They need to start it. You know.
Do you ever get any students who maybe just take it for the credits, but then all of a sudden realize, hey, this printed circuit board thing is pretty cool?
Oh yeah, yeah.
Yeah.
Oh yeah, all the time. It's interesting to watch. Um, it's I actually had in one of my classes a janitor
Really?
who didn't want to be a janitor anymore. I couldn't imagine why. I mean, really, but okay, but he wanted to make a career change, so he got involved with the course. He took the basic and advanced. He became phenomenally great, a good PCB designer, and he then got into a position. This is how it happens. It's where you go. I got to make a change. I got to do something different. I want to learn this, and there are no criterias or anything else like that. You don't need to be a double E. You don't don't have to have special training or anything like that. And I'll tell you, this is on a community college level, and this course that I teach is online. So I have students from all over the West Coast. I've got some in the Midwest, and they take this course, and it is a great opportunity then to break into other areas. And also, as you know, we put some of the top industry leaders in front of these students to say, okay, um, you know, meet this guy. This is who you want to learn from, and you've been one of those individuals I put in front of my students because it's been a phenomenal opportunity for you and for my students to meet you. So I wanted to commend and correct, thank you for that.
Well, anytime.
Yeah,
I don't know. I mean, you had a couple other people in there who are pretty well known too, and they were very fun to listen to. So,
yeah,
but yeah, I mean, it's great to participate in that kind of stuff, and I think it's part of your responsibility, I suppose, when get along far enough in this industry to kind of give back in that way, whether it's working with students or working on a standards committee or volunteering with an industry group, something to
yeah,
help pass on that knowledge to the next generation.
right, exactly. We all have something to give back, no matter what level we're at. There's always something that we can give back to our industry, and this should be our priority as an industry, is to give back to it. I mean, printed circuit board design, all the individuals, the people that I've met in this industry are phenomenal. Best people I've ever known in my life, and it is. I would be complete amiss to not give back. To say, yeah, I'm just going to go into retirement, play golf for the rest of my life, and do whatever, fade into the the dark night, as they say. Uh, I just I I think our industry is at a point where we have to give back. I mean, we're falling behind in our talent. We're falling behind in refilling our pipeline of the next generation of PCB designers and the people that will come behind us when everyone stops. When we're gone, everything else, people who will be there carrying the torch for us moving forward. Um, I would recommend everyone to go through the history of a printed circuit board, where we've come from, some of the leaders of this industry. They still exist. And we're as an industry, we're still very, very young, I would say. I mean, relatively speaking to other disciplines, things like this. And I can tell you that it's good to kind of look at those individuals. I can name a bunch of individuals right now that have impacted my life as a designer and different things.
Yeah, so I think that that giving back that we can do, you've mentioned bringing up the next generation and ensuring that they have the tools that they need to succeed and kind of carry on the legacy that your generation and my generation have helped to create. I think it's
Hmm.
so important, and it's really rewarding working with young people too, especially when they have that like eureka moment when it like suddenly starts to click. Those are
Hmm.
always great.
Right, exactly. And it's fun to kind of throw them in the deep end. I mean, I enjoy this as a professor, is to throw them in the deep end, see if they swim or not. I
That was one of my favorite
remember.
things whenever I
I
gave a
know,
homework
isn't
problem or
it?
something.
It's like great. One of the great moments in the PCB process is that we finished our schematic and everything's great. Everything's good, and we push that initial into the PCB, and we let all the parts come in and all the rat's nest and everything else. It's like that's a like an eureka moment for my students, is because like you literally, okay, we're going to push our schematic into our PCB, and I just kind of take a step back and I say, okay, let's watch this. And it's like the comments are like the best. It's like, oh wow, holy crap, what's going on? It's like,
What's
so
my
it's,
plan of attack, maybe?
yeah, what is my plan of attack? All right, it's like, what has just happened here? It's like, I use an old I we'll get this reference, but a lot of young people won't. There used to be the old Saturday Night Live skit with Mr. Bill. It was like, yeah, oh no,
Yeah.
you know, and that's where I find a lot of students start freaking out, is when they see that, and I go, okay, first off, this is what I literally tell them when they do that: is, okay, take a deep breath. It's
For
going to be
sure.
okay. Okay. It's like, oh my goodness, it's like they just see like total confusion, right? And one of the things that I try to do is I always try to relate things in my class to life and to learning and all these different things. And I tell them, I say, a lot of times life is this way. I mean, you're all you see is all the mess and the rat's nest going everywhere. And that's how you kind of describe your life, is just a rat's nest of problems or issues or different things like this. But let me promise you, there is a solution. There is an answer to those problems you're having. And as we go through them, and I take that student, okay, now this is your next step, next step, next step. They begin to sort those things out, and they get them into the right place, and they start seeing the connections between things. And in life, that's the same exact thing. We put things in place. We begin to say, I see a better way or a better path in my life. I can make some changes here. I find that's a lot of my students. They want to change. And this is one of the things I ask them to do at the very beginning of my class. Very first night, is I say, I want you to sit and I want you to write. And this is not for me, it's not for an assignment, this is for you, is why you want to take this. Why are you doing this course? What is it you're after? And I want you to understand this, because this is going to be what drives you in the future, not just in this class or this course, but in life. is understanding why you're doing something and having that in the forefront of saying, this is why I am here, this is my purpose, and this is why I'm doing what I'm doing.
That's such a great, inspiring message, I think, to folks who are listening. We're
I
getting up
hope.
there on time, but I wanted to ask you for this last question. Where can folks go to learn more about your course and how to enroll if they're interested?
Yes, we're going to provide a link for you to Palomar College. The um, the fall semester begins in August. This is an online class. You can take it from anywhere. It is a 2 night class, a 2 nights a week class for 3 hours each night. So you're going to get in depth here, both on a lecture side and a lab side. Palomar College, palomar.edu college. If you type in that, that will get you into the college itself. What you're looking for is Basic PCB Design 1. That's the course name. And we will provide for you some links that you can go to and get involved. Now, enrollment, I will say there's 25 spots. That's it. 25 spots. After that, people are then put onto the waiting list. The enrollment for this opens on May 12th. This is time that enrollment opens. So we're just coming up very quickly here as we're recording this. So this class will fill up quickly. So if you're interested in taking this course, and it's going to fill up very quickly. So I would get in there, get registered, sign up, and be a part of this. And no matter what you're looking for, if it's a career change or developing your skills as a new PCB designer, whatever it would be, this is where you should begin. I would definitely recommend uh, getting in there, getting registered, and being a part of this program that we've got here. Um, it's one of the very few in the nation that teach strictly PCB design. Uh, this is one of only a handful of printed circuit board design courses in the nation. So this will be a great opportunity for you, and you'll definitely learn something. Okay.
Absolutely. Well, John, thank you so much for being with us today. To everybody that's out there listening or watching on YouTube, we've been talking with John Watson, Customer Success Manager here at Altium. To everybody that's on YouTube, make sure to hit that subscribe button. You'll be able to keep up with all of our tutorials and episodes as they come available. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks again, everybody.